We are now finally coming home. We are having our first Portuguese speaker of the day. It's so good to have a Portuguese on the stage. And Paulo was here last year, and he said to me over lunch that he didn't know much about Bitcoin. And then he sat me down and talked me through a project which I'm not so sure how much I can say about it, so I'll stick to my notes instead. Because Paulo is the founder of Segreen, a Portuguese engineering consultancy, and his argument is that Portugal has a quiet inventory of legacy power plants. Substations, grid connections, permits already in place that are to some extent sitting idle. There are also quite a few Portuguese islands, notably the Azores and Madeira, that run their own mini-grids that maybe we'll go into this afternoon. But crucially, these are not liabilities. They are some of the most strategically valuable real estate in European energy, if you know what to do with them. So this is the local story on Portuguese soil, so please make loads of noise. Please put your hands together for our first Portuguese this afternoon. It's Paulo!
Thank you. So, first of all, let me tell you a small story. 1 year ago, I came here and trying to find some answers for some of my issues in power plants that I run. So I'm that guy that Rachel mentioned in the morning, saying that it's quite nice to have someone coming from 1 year ago and now is presenting something. So something new happens, right? So let me show you this. For me, it's the most beautiful wind park in the world, in Terceira Island, Azores. I'm the responsible for its operation. And it is 6.66 megawatts. And every single night, from 11 p.m. to 7 a.m., we get a curtailment of 3 megawatts, okay? So this is purely wasted energy, clearly. So what to do with that? You know, right? So that made me to think to approach this world. And I met amazing people last year, and I've learned a lot. But really, I got some moments of revelations, you know, some epiphanies. I've learned that we could do frequency regulation with Bitcoin mining. It was something that I didn't expect in the beginning. So I went through all this way, and ideas started to appear, of course. And I started to engage people that I have met here. And I'm going to talk to you about some specific cases in Portugal that, for me, are quite, it's evident that we have to do something about it, okay? So another example of a problem that I deal with, we have a colleague here that is a promoter of solar PV. This is a 4 megawatt power plant that we have installed in Spain. So nowadays we have the duck curve that everybody knows, I think. So it's becoming a real problem nowadays, okay? I loved your pick with that puzzle, with several pieces. I believe also batteries also take part in this, and also, of course, the mining. So today, I'm going to try to tell you what the opportunities that we have, not only here in Portugal, but mainly here that I know, about small hydropower plants, okay? So I work for more than 30 years with all these technologies, basically, but my passion is small hydro. It's where you can be a real engineer. All are prototypes, if you know what I mean. There is not a small hydro from the shelf, okay? Everyone is different from the others. So it's an engineer's paradise. So nowadays, mainly the small hydropower plants are having a lot to struggle to be economically feasible. So that's one of the questions that I'm here for. Sorry? I'm going to explain, my dear. I will try. So this is an installation from with more than 100 years old, still working. So just for the non-engineers, I know that there are lots here. So the water comes here, goes out. It turns the generator. Can you see it? Okay. So, but the sheer beauty of this for an engineer, right? If you like machines, this is art, right? Can you see the beauty of this Kia? No? Yeah, this is in the north of Portugal, Rio Faro. So, why? Why? Well, one of the problems is that we had a tariff that was fixed for producing small hydropower energy. So that is ending. So nowadays, these small power plants have to go to compete with the 100 megawatt power plants in the spot market. It doesn't make sense, but it's how it is. Of course, you can do a PPA, but who cares about this, right? This is small. Another problem that we're having now is many of the power plants that I've worked with, and some of them I've designed, are reaching 35 years old in 4 or 5 years. And then they will lose the license to operate, and they will go to an auction, okay, to whoever wants to bid, to operate them. And nobody will want to do that. Okay? So these power plants will become stranded. Okay? So the infrastructure is okay, but the business model has collapsed. For all of you, this is trivial, commonplace, but for me it's still not. Okay? I still have to think about energy and Bitcoin and being two different sides of the same coin. Well, so the main thing for me is that we can transform energy into a digital commodity. So this changes lots of things in my problems, right? So again, energy is equal to Bitcoin, and now I can produce energy in a remote location, not connected to anything, and send that energy to wherever I want, to Indonesia, say, right? And for me, this is completely mind-blowing, okay? Why small hydro is such a fantastic thing, okay? When Kenji means renewable, you don't mean hydro, I hope. Because it's stable. Hydro is stable. So when you put a turbine of this working, it works for hours, or days, or weeks, or months, in the same power, with the same flow, you know? So it's very stable generation, which is good, of course, right? Also, they have a very high capacity factor. Just for you to get an idea, I work in Kenya. I have some projects and companies there. And the load factor of a solar PV in Kenya is 15%, 1.5. And our small hydropower projects there have 60%, 60, capacity factor or load factor. So 4 times more. The same capex that you put, or the same power that you install, produces 4 times more during the year if it's small hydro. The remote locations, I've explained to you why. They are very easy to operate. Of course, it's a technology with more than 100 years old, since the times of Edison and Tesla and Pelton, Kaplan, all these pioneers. And of course, they are too small to compete or to participate, wherever. Nobody cares, right? The other thing is, if you do an investment in small hydro, you can expect for at least 50 years of working material, working equipment, right? So for you to get a grip of the number of things that exist in Portugal, like this one, the oldie that I've shown to you. So this part of the map is somewhere here, okay, in the north. And can you spot these blue dots? Okay? These are old power plants that are stranded, abandoned, okay, underutilized, okay? So from here, Santo Tirso to Guimarães, our cradle, cradle, thank you, our cradle city, Portugal was founded here. So it's 10 kilometers. So you see the number of power plants that we have that are completely stranded, okay? So I'm going to show you two cases, okay? One is the existing and very productive power plants that, in my opinion, will become economically stranded. And the case two is the other, the saddest one, is the power plants that are abandoned. I'm going to show you some specific examples. Huh? Of course, keep in mind that we have, every time we have grid connections, I don't know if we really need them, okay? It's something that we are still working in our business model. But the most important thing is that the infrastructure is there, okay? I'm going to show it to you. So the first example, me as a young engineer, many kilos ago, you see this part is this one. So you see the environmental impacts that some may claim that exist. No, it's minimal, okay? Because we do things, this is really small hydro. We do things small. So it's 850 kilowatt with a grid connection of 15 kV. Refurbishing costs 0. So it will go to the tariff, doesn't exist anymore. And in 5 years, it will go to an auction. And I'm pretty sure it takes serious risks of getting completely abandoned, which is a shame.
Is that you?
Yes. No, the main goal was to show this. Huh? Okay. Now, the case two. Look at this. 2 turbines, 2 groups, generators. Look at the size of the room, the power plants. So it looks like a small church or something like that. It was beautiful. We find this by the dozens in Portugal, okay? And you see, again, the design, the concept of those days, more than 100 years ago, okay? Now, we could rebuild this easily to have 1 megawatt working perfectly, okay? With some costs that I estimate roughly 1.3 million. Just for you to get the idea, the canal of that power plant, the canal, another one, the building. So everything is there, actually, right? It's not expensive to bring this to life again, except for the equipment. And please bear in mind that the most expensive equipment is the medium voltage switchgear, which it doesn't exist here, okay? We don't need it. Another example, Rio Dão. So the Portuguese understand the importance of this river in the winery and other things. But the license is 95, so in 3 years it will go to auction. Installed power 300 kilowatt, completely stopped. So you see the dam, the canal, and the power plant building. This plant is ceased to function, is stopped. Another one, this, I brought this one because it's near Lisbon, it's 1 hour from here. you can see again the beauty of the installations. Huh? Those were different days that we did everything beautiful, right? Look at this gear, all the engineers. So, I've been studying this place for some time. And I hope in 1 year we meet again here. And I can tell you, look, some pics of the reconstruction that I'm doing, okay? Because I believe in this one will be my first to recover. So I estimate something like 400,000. Still have 5 minutes. A bit of technicality just for you to understand the reasoning, the engineering reasoning. So this is what we call the flow duration curve. So we do the flow, the cubic meters per second, and here the days of the year. And we start in the most rainy day till the least rainy day, and we get this curve, okay? So this is energy, okay? If I install 2 cubic meters per second in my turbine, I will be able to seize all this energy, right? Follow me? Of course, if I install 3,000 kilowatt, 3 cubic meters, I produce a little bit more, but it's much more expensive. So there is a not optimal point where I say, no, I have to install 1.5. It's my optimal flow, right? So then I compute, and then in the end of the day, we have the estimated production. Of course, this has to do also, now in this case, with the Hasek's matter. So how to cope one thing with another, okay? Just another example, just a teaser, okay? Our beautiful power plant with 2 magnificent turbines is completely stopped, stranded, rotten. This is, for me, this is what is called industrial archaeology. Are you familiar with the term? So this is it. Now, some of my worries, of the guys that are working, we have several guys who are working on this, of course, the capex, okay? Never forgetting that we will not be connected to the grid, if possible. Then, the hydrology, as I've told you, of course, the minor side. This is important, okay? You have to get the finance for this. And, of course, the other risks related to operation. So we have to sort out still these matters, and they are present in our... we are doing some, of course, some tools to turn all these analysis faster, okay? Coping the energy side, the hydrology side with the mining side. And just for you to get an idea that what I've shown to you happens all over the world, okay? For instance, I work a lot in Africa, and I worked a lot in a small country called Saint Tomé and Prince. We have 5 of these power plants, up to 2 megawatts each, okay? Completely abandoned. And this could be a way of recovering it, okay? Even providing some energy to the local populations, as Greatless does, okay, in Africa. So, I find it in Spain. I find this in Kenya, Uganda, wherever I go, okay? This is what I'm still thinking after 1 year ago I met you, and it's been quite a thrill, okay? I would ask you, Miguel, this is A power plant that I designed more than 30 years ago. Look how small it is. The interesting thing is you see the flow that is coming out from the turbine. It's only a small portion of the flow in the river. It's underutilized, but even so, you can have the grip instantly. That we work lots of hours during the year. We have a very high capacity factor, right? This is in the center of Portugal, Tondela, for who knows. Another example. I didn't notice this. But just for you to get an idea of, again, the state that more modern one that is going to go to auction very soon, in 1 or 2 years. What will happen to this if we don't get it? Okay? That's the question. And that's it. Thanks.
Thank you so much, Paulo. Muito obrigado.
Bye.